That was you, wasn't it? Hey, for what? Are you?
All right, so so
I always do the minimum.
let's talk about that bit. All right, so today's stuff is actually really easy, but it's not a lot of it's not very complex thinking, but it's just make sure you know it, and I'm trying to record it. And thanks to Safa, let me borrow her iPad.
Mr. Ye, and when you calculate where it converges to, do you use the original function and just put the bounds set to n equals whatever you find?
What are you talking about? What are you talking about? Error?
N equals 1.
A to the n. All right. All right, so what we're gonna do is we're gonna start this and we're gonna come back to answer the question. So we finish this up. Tuesday's gonna be a test for this one. Monday you can review all the stuff. The only thing that I probably can do is yeah, Monday is gonna be a review, so I'll give you kind of review stuff. But if you do everything homework now till now, you should be fine. And then what we're gonna do is we're gonna talk about absolute convergence. So absolute convergence. And when we talk about absolute convergence, we basically said if the series summation of n equal to 1 to infinity to absolute value a to the n is converge, if that's true, then the series summation of a to n also converge. And later we're going to talk about this as an absolute converge. Okay, it's absolute converge. Then you say, okay, well, when do we use this for? We're going to give you a situation that we can use for this. Let me make it this bigger. Okay, we're going to give you a situation that you can use for this. Okay. But meanwhile, I'm also going to talk about definitions of absolute TE absolute converge. So if it's absolute converge, then when so we have says first situation is the series summation of a to the n is absolutely convergent when summation of a to the n converge. So it's kind of like previous statement, but at the same time, we're going to talk about n conditional converge.
Something converges, it's absolute converge.
No, if the absolute value of the series converge, then the series also converge. Now, yeah. So conditional converge. So we're gonna talk about it in a second because right now kind of seems like kind of confusing. So the second is
Should there be an absolute value on the when? It's like the summation.
yeah. Thank you. So the series of summation of a to the n is conditional converge when two things happen. When summation of a to the n converge, but summation of absolute value of a to the n diverge. So this is the conditional converge is a little bit different. So a series can converge. However, the absolute value of the series is diverged, then it's conditional converge. So if you want to think about it, there was kind of in terms of those absolute converge. So there's two types of converge. There is conditional and there is there's a third one is diverge. So we're gonna start with this first situation. When do we use absolute convergence? When it's something like sort of alternating, but it's not alternating. And this one will be on the test. So this is a test questions right here. I'm gonna tell you it's on the test. Okay, so will be something like this. Summation of n equal to 1, infinity, and sine of n over n squared. And you're gonna be like, how is this sort of alternating, but it's not. Okay, so the true definition of alternating is what? Plus, minus, right? But what if you have this situation? You're gonna say, okay, let's write our first few terms. Sine of 1 over 1 squared plus sine of 2 over 2 squared plus sine of 3 over 3 squared plus sine of 4 to the 4 squared plus sine of 5 to the 5 squared. Now there's a reason why I keep on writing. Sine of 6 over 6 squared and the plus last one, sine of 7 to the 7 squared. Now you're gonna be like, well, what is 1? What is sine of 1? What is sine of 1? It's a positive or negative? It's positive. Why sine of 1 is positive? Because do you remember that this is pi, right? Pi is equal to 3.14, right? So sine of pi is equal to what? Sine of pi is 0, right? Or sine of 0 is 0. So where's sine of 1? 1 is roughly 1/3 of this, right? So this is a sine of 1. Sine of 1 equal to positive. Is that okay? Sine of 2 is probably here. It's still positive. Sine of 3 is here. Then it's still positive, right? So technically this is a positive, 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 negative, 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 positive. Because 6.28 is still negative.
This is what I was trying to say the other day. it's not technically alternating.
Yeah, it's technically okay. So I didn't understand your question. So this is not technically alternating. This is just a kind of having some plus sign, some negative sign, but it's not exactly alternating. So what you can do is we can do absolute value of this one because we can say, hey, what happens sine of n over n squared? So that makes everything is positive. What? Something I did wrong? You sure?
This year, does it have to be alternating or for absolute and
So yeah, it doesn't have to be like something is not exactly alternating. You can use the absolute conversion definitions because if this is converge, it's absolute converge. It's absolute converge is converge. So it's the highest level of case where they are converge. Okay, they are for sure converge. Doesn't matter what.
okay, so it doesn't matter if it's alternating or not.
It can alternating. So,
But it doesn't have to alternate.
but what's your definition of alternating?
Like flipping back and forth between positive and negative.
That's a true definition. Yeah. So this one can also use on the true alternating. Can also use on the one that's not exactly a alternating, not definition of alternating. Alternating has swap sign in each term, but this is the case. It doesn't swap sign on each term. It swap sometimes 3 terms, sometimes 2 terms. Sometimes I don't know. Depends on the remainder of 0.14. How many times you have 0.14, then you got 1 extra term. So it's not really exactly. It's not a definition of alternating.
But if it's not any sort of alternating, not like definition or like if it stays positive the whole time, you can't use absolute convergence.
We're gonna use absolute convergence a lot because later we're gonna use actually more with the ratio test and all that. The ratio test is gonna be start with the absolute. It start with the absolute value. So you can use it on anything.
Okay.
You can use it on anything.
Okay.
So in this case, then we can just say, oh yeah, that's just a sine of n over n squared. So we can do a direct comparison test, right? We can compare to 1 over n squared. And since sine of n over n squared is always usually less equal to 1 over n squared, right? So this is converge due to what? P series. Okay, good. You guys are awesome, right? So P series. So this is less than a 1 over n squared. So this also converge. But not only any kind of converge. This one's absolute. Absolute converge. Absolutely converge. Because we put an absolute value on it. Yes.
So would our proof be like an absolute convergence due to DCT, or
What'd you say?
would our proof be like an absolute convergence due to DCT, or like how we like find out?
It can be different, depends on the condition I give it to you, depend on the question I give it to you. So later on we can show you different question on your homework, gonna do a different style question because not always you're gonna use P series or not always you use direct comparison test. You're gonna use any test that's available to help you to solve a problem.
Yeah, that's what I'm saying. Like, you would say absolute convergence do that test.
No, they won't say do that test. They will say if this is question converge or not. You can do an absolute if you have those kind of situations. Yes.
Absolutely convergent is the absolute value of convergence.
Yeah, absolutely welcome. Because that's the highest level. We're gonna show you the other situation. So remember that alternating harmonic, alternating harmonic. Alternating harmonic looks like what? It looks like summation n equal to 1. This is infinity, and it looks like something like -1 to the n plus 1 and to the 1 over n, right? Right? So it looks like this, right? Seriously?
throw his phone out the window.
I should.
Instigator.
So if this situation occur, this situation occur, we're gonna do the normal situation first. What kind of series is this? Alternative harmonic, right? But we can do alternative series test. So we can say, oh yeah, this is alternating. So we put a check mark it. We say the second one limits n approach infinity on the sequence, which is 1 over n is equal to 0. We also put another check marker on it. We says another check mark is 1 over n plus 1 is less than 1 over n. That's always true. So alternative series test says is converge. Now remember, I don't know how to say that word. Remember, if I were to do absolute, so absolute of -1 to the n plus 1 times 1 over n, this is more stringent, right? Stringent, like more.
Strict.
Yeah, strict, but that's another word. Stringent is more like higher requirement. Huh? Stringent?
I'm pretty sure.
Yeah.
Strict.
Okay, well, you can say strict.
It's stricter. It'd be stricter.
Okay, stricter. Okay, so this will be a stricter test because if you do this test, you'll find out the absolute value will go away. Take out the negative sign. So there is no alternating anymore. So you're going to have summation of n equal to 1, summation of 1 over n, rather than -1. Does that make sense? So what happened when this test we do? Yeah, this one's diverge. We know that very easy. We can say this is harmonic. Harmonic series. So absolute value is more harder test. You realize that absolute value is higher requirement because you could have some diverge here. Because if you do absolute value, you just take a -1 away. Now this is a harder test. So it's a harder test. It's already approved. That just says you already passed AP Calculus with a 5. You are probably more likely going to pass Algebra 1 EOC. Right? So this is the higher level test. So you're absolutely smart in this case if you've taken the... Huh? Yes, Aiden?
So what was the answer?
Answer in this case will be a conditional converge. So it's like saying like, yeah, you gotta find AB, but you got like 2 in BC. So you are somewhat smart, but you're not really, really smart. Yes.
For the sine of n problem you did earlier, how did you know that it was absolute convergence and never absolute value?
Because if we absolute value, it doesn't matter what sine of n result is going to be. Sine of n result is going to be positive, negative, positive, negative. We don't know which term is it. But we absolute value, we're going to say even sine of 4 is supposed to be negative value, will actually end up to be positive. So, but we still, so that's why we do direct comparison test with 1 over n squared. And that way, we know it's absolute, it's still absolute converge. Does that make sense?
Wait, so what would this still be out?
This is conditional.
Just an AST proves converge. It's not always converge.
Yes.
So, doing absolute value to tell you what type of convergence it is?
Yes. It will. So absolute value is like a BC test. You pass the BC, more likely you can do well on AB, right?
This value.
Or pre-cal or whatever. Supposedly. So that's at the highest level of more stringent test compared to any other test. Harder test. to get converge. Because obviously, this case, we have a diverge. When we do absolute value, we get rid of negative sign, you actually get rid of. So, I'll give you some questions, so that way you will see it. The first case is this. First case is going to be negative 1 to the n of n factorial over 2 to the n. The second case I'm going to give it to you is summation of n equal to 1 and infinity of negative 1 to the n over square root n. Third case is actually interesting. Negative 1 to the n times n plus 1 divided by 2 divided by 3 to the n. Last one. Don't worry, this is the last one. You finish, you can do homework. So start with the first one. This one, this number, this n. Which apps does Safa? Good Notes? You had to pay for Good Notes?
I pay $9 a year.
Oh, okay.
Oh really? No, I pay
Mine's $20, yeah.
And then I get like unlimited amount of like pages per year. I get unlimited amount of pages.
I can't believe they charge you for pages.
I know, right?
That's what you have iPad for. But then you say we'll charge you, we give you unlimited. If you pay $5, you can only get half of unlimited. So, unfortunately, that one you just have to know the numerator is going to be way faster compared to denominator. There is no exactly way to do it because you cannot take a derivative n factorial. Huh? There is a one way to do it.
Wouldn't that make it diverse then because the numerator is bigger? Yeah.
Yes, it is. This is diverge.
Oh, so
Why are you doing the other
can't do
side?
it.
No, but you have to know like when's diverge, when's a conditional converge, when's absolute converge.
So that means if it's divergent, it's like completely divergent.
Yes. So if something go to diverge, guess what? That's a diverge.
It's always
That's like you can't even pass algebra 1 EOC. Shh, give me a second. Like your highest level is absolute converge. Your second level is conditional converge. Your third level is diverge. So yes, you can get diverge. Diverge is like I would say algebra 1 EOC. If I give you algebra 1 EOC, it's like a divergent test. Oh yeah, you cannot pass it. You're stupid. No, cannot say that. No, they're not stupid.
The normal test, if we get diverge, it's always less. But with the normal test, we get converge, we need to do the absolute test. And if that's diverge, then it's conditional, and converge, it's absolute.
Yes. So you think about algebra 1 EOC, maybe pre-cal. Then okay. No, just type in. I don't want to know your password.
Ever again.
I don't know. I might steal it. You never know. Like when I'm missing an iPad, I might steal it.
It's literally just like it's like 3.
I like your paper though.
Thank you.
You put a paper on the top, right?
Yeah, the paper screen protector.
Yeah. I didn't like it before, but I don't know why I like it now.
If you want to think the thickness, this is what controls thickness.
Yeah.
Yeah.
I got you.
Mr. Yes. It's your number 2. You just swap up. You just swap up the value.
And just one over it.
Yeah, 1 over square root n, but what is 1 over square root n though? Diverge, so what is this one? Huh? Conditional, yes. What?
Oh.
But if it converges, then you check if it conditionally converges or if absolute.
I don't even see it hold.
Hold on. Zoom into the third one.
You can't do that. You can't do that.
Hold on a second.
Can you move your goddamn head?
N squared is always going to be Converge. N squared plus what makes sense to me to math.
Yeah.
No, it's okay. You'll be fine.
So the next one goes away. Because
More black hair. She said that you don't. She doesn't
This is all the white hair from you.
all black hair. You're welcome. You're welcome. Yeah, I didn't that has to be it.
All right. We start with the first one. The first one is says, okay, well, it's alternating. We have one check mark. How about limits as n approaching infinity n factorial over 2 to the n? Well, that's equal to what? It's infinite. But we're going to come back to deal with this in a second. So how do we know that it's going to infinite? Infinite is keep on increasing, right? We'll show you another way to show you that it's increasing. But what is the, so this one is, this is not it. So we say it's cross out, this is diverge. Because it's going to go infinite. So how do we sum something is going to go to infinite? So therefore it's diverge. Now for this one, you can, yeah, you can say, oh yeah, I have, I can do a alternative series test and AST. AST says what? A is correct. And so limits n approaching infinity of 1 over square root n is equal to 0 is also correct. And then what do? The last one is 1 over square root n plus 1 is less than 1 over square root n. That's also true. So this is a converged series. However, if you do an absolute value on it, what will happen? Absolute value of negative 1 to the n over square root n. That's going to be 1 over square root n. P series says this is diverge. So this is conditional. Now, what's cool about this type of series is not exactly. So this is the same situation or what Joshua was saying earlier. It says, what happened with this kind of situation? Well, if I pay attention to the first 6 terms, you're going to see something special. Brandon, put the fucking phone away. Jesus. I don't like to get pissed, but
Hit the questions.
I don't give a shit. It's so disrespectful. If our administrator is just gonna take away your phone, I'm being lenient for you, but you don't have to be this. My goodness. It's so disrespectful, just not respectful. I mean, you can don't listen to me, but you take out a phone, that's just really disrespectful. Like, I don't usually curse at people and live stream it. I don't give a shit. But you are not respectful at all. Okay. So if you do absolute value of this, but the problem is what kind of the alternating is this? It's actually pretty interesting. If n equal to 1, what am I gonna get? 2 and 2 cancel out. That's gonna be negative, right? What happened n equal to 2? Wait, n equal to 1, sorry. N equal to 1 is 2 plus 2, 1. Okay, n equal to 2 is what? 3 is what? Negative. What happened n equal to 4? Oh, I'm sorry, n equal to 3, sorry. Is what? Is what? Is 6? 6 is positive or negative? What's n equal to 4? Is 10 is positive or negative? Positive. Okay, so it's gonna be negative, negative, positive, positive, and then you can go back to 5 and then go to 6. It'll actually negative, negative. So this is a way to write it in a way is alternating every other term. Like, I mean, not every term, every 2 term. It's alternating every 2 term. But it doesn't really matter because today we say, well, this is a kind of complex. I'm just gonna put absolute value on it, see what happens. So n equal to 1, infinity. So if we do absolute value of this, so it doesn't matter what this power is. So that is 3 to the n. So if you do that, there's gonna be summation of n equal to 1, infinity of 1 over 3 to the n. And then where it's just this is geometric series, this converge due to geometric series. You have to write it down on a test. Which kind of series is this? You cannot just say this. Now, for this one, well, this one's alternating because this one's not alternating. So the only way, so when you do an absolute convergence right away, is the one that's not alternating. It's not exactly alternating. Like n sine of n over n squared, that not exactly alternate every 3 term. This is every 2 term. Yes.
So if it's not exactly alternating, you can still do the test and get converge.
Yes.
So then it's absolute converge, or
It's gonna be absolute converge.
okay. So if it's not exactly alternating and you still get converge, it's absolute.
Because you do the absolute conversion test. So it's fun that if you have something like this, you can just you can do absolute value on it because absolute value on this one, what happened? You're gonna go back and you say, well, that's a diverge, right? So then you have to say, well, we have to do the normal test again. What kind of test? This is alternating, so A is check, and limit and approach infinity of 1 over ln of m plus 1. That's equal to 0. And let's check. And then limit of m plus 1 of m plus 2 over 1 is less than 1 over ln of m plus 1. Also check. So, but if you have 1 over ln of m plus 1 here, summation, and greater than 1 infinity, you can do different tests to figure out this is actually diverge. And if this is a diverge, then it's going to be conditional converge.
Wait, what test do you do for that?
Which kind of test you want to do?
I don't know.
You can compare to 1 over n.
Compare.
You can do compare a lot of things. You can do limit comparison tests. So it depends on which one you like.
Okay. As long as you know it's correct in there. Like you know with this one's correct. This one.
So this one is a diverge. So it's a diverge, then it's diverge. A conditional converge. So conditional converge. Okay, you guys practice practice a homework question.
Yeah, no.
Because one of our ends is always like borderline there.
Why do you keep on popping back out?
When you double tap it, it like goes back up.
Well, I didn't tap anything.
Oh, I don't know. But if you double tap it,
Okay, homework question. A lot of people actually like this homework, so try it. Third period, they try it and they actually like it. But yeah, so it's not as bad as you think. Just try it. That's okay. I'll turn it off. I'll give it back to you. Thank you so much. Yeah.
So like, if I have to do the original,
Yes. I think for this one, that if
above one, that is below one, that converges. All these theories find out.